Good evening. I'll just wait for 1 or 2 minutes also to see if anyone else is joining, and then I'll start today's class. Very warm good evening, everyone. My name is Sri Lakshmi, and I'm the TA for the Electrochemical Impedance Spectroscopy course. And so, this is the 8th week of the tutorial, of the session, and I welcome you all for the course today. So basically, in the up to what you saw the last week, that is up to your 7th week, you were mostly dealing with what is known as, the impedance based analysis only when, with an assumption that it is kinetics controlled, there is no effect of mass transfer. So even the mechanisms you saw, you are considering a case where there is no mass transfer happening. So what does that mean? If there is no effect of mass transfer, it means that whatever is the concentration of any reactant in the bulk, that is the same amount. The same amount or that concentration is the same even at the electrode electrolyte interface. So whatever is available in the bulk is equally available at the surface for the reaction. So in such a case, we'll say that there is no mass transfer effect and it's kinetics controlled, and you get the impedance. But when diffusion comes to play, though, okay, in real cases, you cannot say that whatever is available in the electrolyte is available equally at the electrode electrolyte interface. That is not possible. Sometimes the reaction speed will be very fast that these species will not be able to diffuse from the bulk into the electrode electrolyte interface. So in that case, the reaction is stopped because of the absence of the desired amount of reactants. So this can be considered as the case where where the case where the diffusion limitations comes to play, or the diffusion will affect the rate of the reaction. So when you take into consideration the diffusion affects the impedance, what to say, the impedance plot will be totally different from those cases that you have seen before. So that is what we are going to look into. So so when there is a diffusion happening, diffusion effects coming to play, the species are not fully available at the electrode electrolyte interface. So there is a change in the concentration of the reactants in a small, what to say, in a small region between the electrode and the electrolyte, which we say as the boundary layer. So the thickness of the boundary layer depends upon the mass transfer limitation. So the thickness can vary. It can be a finite thickness to as high as a semi-infinite condition that we are taking into consideration. Yeah, so that is the brief background of what we had seen in the last week. So just giving a small introduction, then we'll move on to solving some problems. So just before that, yeah, so of what I said, there is an electrode and there is a bulk. So here the concentration of species will be something as a concentration of A bulk. But in this region, okay, as it comes to the electrolyte, I mean to the word say electrode, the what happens is there is a small region where the concentration of the reactant changes, or it depletes towards the electrode electrolyte interface. So this because of the diffusion effects, and this is what we call it as the boundary layer thickness. Okay, and here the at the electrode electrolyte interface, the surface concentration can be represented as CAS. So in the kinetic limited cases that we saw, kinetic limited cases we saw that CAB equal to CAS. So we assume that it's the same everywhere and there is no effect. But when mass transfer limitations come to play, what happens? This no longer equal, and instead CAS will be a value which is smaller than CAB. If concentration of A species is getting consumed at the electrode-electrode interface, so at the surface the concentration of A keeps on decreasing and it's lesser than that in the bulk. So for a simple electron transfer, if you had done the kinetics limited case, you would see that you will get a simple loop, right? For a simple electron transfer. So you know this R solution and this the RT equal to RP. But how will it be for a mass transfer limited case? So this is just the gist of what you had seen the previous class. But if it was mass transfer limited, so you will get something. You'll get something of the form like you'll have a circle and there will be diffusion coming to play. Sorry. You will have the diffusion coming to play and it will be something like this. Now, how exactly it goes? This will be a 45-degree line and you say that's known as the Warburg. We use the Warburg to show the, what to say, it's the diffusion limitation. So this is the case of semi-infinite.
Ma'am, here how to find RT and RP? Is there any relation? RT, okay, we can find from the semicircle end,
Yeah.
but RP finding how to find, because explicitly it was not told in video, so that doubt is there.
Okay, for the semi-infinite case, you will have to do either by mechanism and then you will have to do omega tends to 0. Picturely, you
Okay.
won't be able to do. But if the thickness of finite thick, if it is of finite thickness, you will get something of this form. It will be, you will think assumed, so you will, if you do it at lower and lower frequency, you'll get something like this. So this is for a finite thickness.
So you will discuss all the cases, no? Here,
All the case in the sense?
means like in infinite and finite and all means you have only initiated now. So
Yeah.
after this, whether you will be doing all the cases, means you will be showing all the derivations here, means only brief introduction.
Derivation, it depends. Like last time, students had asked me to actually solve the assignment questions. So if you all require, I can show you the derivation. Might be it will go to the next class also. Okay. Anyway, if
Okay,
anyone is interested, I'll show. That's okay for me.
okay, ma'am.
Yeah. So yeah, so this what is the so you have the diffusion. So if it is infinite, semi-infinite thickness, you will get something as a straight line, and it won't meet the axis. What does it mean? Because it's not meeting, it is because the resistance is high. Okay, so it's a finite thickness, it will somewhere meet, but it will take a longer time. So it won't be an exact semicircle, it will be a straight, somewhere like this, it will be straight and then it will be coming. So that's about that. So one way to overcome the diffusion limitation, people do stirring. So at that point, I'll have to talk about the rotating disk electrode. So basically, when I'm doing rotation, what I'm providing some external means by which the species can diffuse to the electrode-electrolyte interface. So in such a case, the diffusion effects can be minimized. So as the name suggests, you are rotating something. So when the rotation speed increases, it helps to improve the diffusion limitation. I mean, it will try to suppress the diffusion limitation. So basically, you're trying to improve the mass transfer. So yeah. So in such a case, the thickness of the what is it? The boundary layer can be given by the Levitch equation. So that is given as. So this
Is
equation is
it
known as.
D0 or DA?
So
1.61 into D0,
D0 or.
DA.
Yeah, so if it is species, I can represent that as dA of the species. So I've just given a general notation. So it corresponds to the diffusivity of the species. If it is some A species which is getting consumed at the electrode, I can write it as A. So it's just a notation.
Second
Okay.
notation is omega. Is it omega raised to minus 1 by 2 or something else?
No, we say that as psi.
But what
So
sir has given is this
okay. Omega
omega
also you can write. So
theta.
see all
Both are
this yeah, both are same. So notation, it depends, varies, right? So basically it all means the same. So here this is the diffusivity of the species. So this diffusivity of, you can use the notation which sir has given. So basically the terms remain the same, notation might be different. Diffusivity of the species. And the unit is, we should be careful with the unit because this has with this 1.61 conversion factor is for a particular is obtained, it's an empirical formula, and 1.61 is obtained for the given set of parameter. I mean, the parameter should be in a particular what to say unit, so that you get 1.61. So be careful that you put the notations properly. So dA is the diffusivity of species, and psi or omega. So okay, because sir has written, I don't want anyone to get confused. I'll replace this as omega.
omega subscript R, like that way sir has written.
Omega.
Omega subscript R.
Oh, okay. I hope. Okay. It's okay. So there's nothing but it's a rotational speed. Okay. And this, the unit should be radian per second. And finally, it is the kinematic viscosity term. So just you may get 1 mark question or something where you'll be given all the terms and I mean values, and you'll be asked to substitute and find the thickness. So in that case, please make sure you don't what to say, mess up with the what to say, units. So if the rotation speed is very large, what happens? The diffusion effects will be minimum, and you will have a finite thickness. But for an unsteady condition, what happens? The diffusion effect, diffusion limitation will be more, and you will have a semi-infinite boundary layer. So that is what you have to know. So this is a brief introduction about what you have learned.
Now here rotational speed is in question. It is given in radian RPM,
Ah,
revolution per minute.
yeah.
Whereas, so suppose they have given 225 revolution per minute. Now you
Hmm.
can see the other in other units it is second.
Yeah. You have to
If
change it.
so we have to convert it into minute into
Yes.
second.
Yeah, you have to. So that's how it's done. So basically, yeah. So that's how I told you, right? The unit should be same. That's why I've written down the units. That's very important. These should be the units when you're finally substituting into this equation. Okay. So the if I in terms of yeah, tell me.
Excuse me,
Yeah.
whatever the answer we are getting final,
Hmm.
then suppose we are getting say 0.00831400, but they
Hmm.
have given fill in the blank
Hmm.
micron or something like that. So how to
Okay.
convert that into micron means what we are getting that is okay, or we
You
have to
have to
convert it
convert.
into
Yes, yes.
it is
You
10 to
have
the
to,
power minus 6 means they have given
uh,
micron thickness
okay.
delta is equal to something.
So what
Or
unit
else
you
if
are?
you give some parallel example means then also you will get it.
I didn't get you what you're telling. See, what I'm discussing is the assignment question. So I can discuss that only after the solutions are released, after submission. But still, I did not get your
Okay.
question. Could you please once again tell me?
I am asking after multiplying all these things means we are given uh, this diffusivity of species that value is given, then
Yeah.
viscosity is given,
Mm.
then rotational speed is given. If we
Mm.
substitute all these three value
Mm.
and convert this into RPM into revolution per second, then
Mm.
whatever the answer we are getting,
Mm.
what should be its unit? Means here they
It
in
will be
filling the
given
blank
in
they
the
have given
question, right?
uh,
It's given in the
that is
question,
coming.
right?
But our answer is suppose my answer is coming 0.00831400. Now should I
Okay.
convert this into micron or some? What is that unit? Micron or what? Means how to do? Means
You have
last
to
I am
convert
asking.
it. You have to convert it into the value which is given in the question.
If we multiply all these things, then whatever unit we are getting, that will be not automatically micron.
No.
That will be in which unit, so that I can convert from that unit to micron. So whatever
Okay,
the unit I
it
will
will
get,
be in centimeter.
it will be in centimeter.
Yeah.
So from centimeter, I will convert it into
Yeah.
10 to the power minus 6
Yeah.
means micron.
That you have to check. Just check the conversion. I'm not sure, like when you directly ask. Just check that and then, okay. I'll also check and I'll let you know. Okay. Mm. Yeah. So, yeah. So, when if I'm representing it in terms of equivalent electric circuit, as you had, so till now you saw a case where you get something like this. You have the double layer capacitor and the solution resistance which is in parallel to something. So if in this case I'm saying I'm getting like this, This is kinetics limited. So how will it be for mass transfer limited? Who can tell me? This is for kinetics limited. Now how will it be for mass transfer limited? You'll have the same resistor. Along with that, you will be using Warburg, which is another, like, you'll have it in the circuit fit parameters. You'll have to put that in parallel to anything to integrate the diffusion effect also. Okay, so this is the difference in the circuit fitting. In case you see some 45-degree line, you will have to include the Warburg and then try to fit the data. Okay, so before moving on with the next uh, derivation, there are two derivations basically. One is for semi-infinite and finite. I'll try to finish one derivation today, but before that we'll discuss few questions. Okay, so yeah. So there's an elementary reaction. So there's assignment and there's assignment 5. So the first question is, consider an elementary reaction where M solution 2 plus 2E minus, forward reaction rate constant is K1, backward reaction K minus 1, and it's giving M, where M is the metal, M2 plus solution is the metal ion in the solution, F is the Faraday constant. So you're supposed to find out the Faraday current density due to metal deposition. Please do it and let me know the answer.
The answer would be, I think, fourth option, because here two electrons are there. So 2F
Yeah,
into K1 M solution minus K minus 1.
yeah, correct.
Fourth one.
Yeah, fourth one. So you should be careful when you are writing it. You have the forward reaction and the backward reaction. So so you all know the IF formula is equal to NF into rate. So here the number of electrons are 2. So you have 2F. Okay. And what is the forward reaction rate? That's nothing but you have the K1 rate constant into concentration of M solution. Okay. And the backward reaction, you have K minus 1. So you can see the simple electron transfer reaction. So for constant M, you will take the solid concentration as infinity, and this is how you get. Is there anyone having any doubt in the question? I think it's a straightforward question, right? So I'll move on to the next question. In the above reaction, the rate constants are given by Ki equal to Ki0 e raised to Bi into E, BIE, where E is the measured with respect to equilibrium potential. K10 equal to 10 to the power minus 4 centimeter per second, and B1 and B minus 1 values are given, and the concentration is 25 millimolar. So you're supposed to determine K minus 1 0. Please do it. Any idea? So how will it be for equilibrium? So here the condition you will be using is at equilibrium. So at equilibrium, you'll have K10 into concentration of M solution 2 plus equal to K minus 1 0 into 1. So now who can tell what's the answer? Any answer? I've given the formula now, it's a substitution. Any answer? No, in that case I'll do. So K10 value is already given. It is 10 to the power minus 4. And M solution value is 25 into 10 to the power minus 6, because I am converting it in terms of moles per centimeter cube. So finally, I'll get something of the form 2.5 into 10 to the power minus 9, because that's how it is required. They have told in terms of 10 to the power minus 9. Am I audible?
Yes, you are audible.
Yeah, sure. Okay, so here the answer should be 2.5. Okay, now moving on to the next question. The magnitude of the cathodic current density at E equal to 0.3 volt versus equilibrium potential is in microamps per centimeter square. So how do you do it? Any idea? So the cathodic reaction is the backward reaction. Okay, so you're supposed to find out the current density for the backward reaction. Okay, so what is the current density for the backward reaction? Who can tell the formula? So what is the equation? Sorry. So the question is, what is the cathodic current density? Who can tell me? So what is the formula? No answer. Okay. So what is the current density for the backward reaction? Who can tell the formula? How do you write it? NF into rate. So what I'm asking is, what is the rate expression for the backward reaction? It's nothing but NF into backward reaction is nothing but K minus 1 concentration of M, which is solid, which is nothing but 1. So now what you have to do, you know what is N value? It's 2. You know F value, K minus 1 value. Who can substitute and tell me what is IF value? Any doubt? Are you able to follow what I'm telling? Like, yeah, at
Yes,
least
but
yeah, tell me.
derivation means we don't know. Suppose n is 2, number of electrons is 2.
I didn't get you. What derivation you're talking about?
Means how to, what value should we put means
Yeah,
Faraday constant is 64625 multiplied by 1000.
96,485 coulombs per mole. So, you know, you will report current density in milliamps per centimeter square. So, this coulomb, so this nothing but 96,485 ampere second. Coulomb is nothing but ampere second. But you need it in mole per centimeter square, right? Or it should be in so you know current is something in milliamps. So here it is in ampere. So what I can do is I can multiply it with 1000. Is this part clear? Is this part clear? Till milliamps second per mole. Now what is k minus 1? K minus 1 is what you found over here. This is 2.5 into 10 to the power minus 9. Is this clear? Are you able to follow?
While converting from ampere second per mole to milliampere second per mole, what we have done, it is same. You have written
No,
96,485.
sorry. Into
So
10 to the power 3. I forgot to write that. Ampere to milliamps multiplied by 1000. What do you get? Anyone has got any answer? So when you finally substitute, you will have 2 into 96,000. So you have n corresponding to 2 into f value 96,485 into 10 to the power 3. K minus 1 is 2.5 into 10 to the power minus 9. When you substitute all together, what you're getting? See, many of you had asked me to solve the previous assignment. That's how I'm solving. It will be useful if everyone can, you know, even if you make mistake, if you can speak it open, we can help to identify where you're making mistake. That will help you to not lose marks in your final exam. So you should get around something like around 193 to 196 or something. In between that, you will be getting the value. Okay. Shall I move to the next question? So the next question is similar to this
what
one.
you have given, excuse me,
Yeah.
you have given is in milliampere per centimeter square,
Yeah.
whereas in answer it is microampere per centimeter square. So
Oh, sorry. Wait.
the
Sorry.
correct
I have
answer
written.
is
Yeah, I
0.9
wrote
to
the
1.
I wrote the wrong answer. I wrote the next question's answer for you. I have solved over here. So if anyone has any doubt, just multiply and check. It will be 2 into 96,485 into 10 to the power 3 into 2.5 into 10 to the power minus 9. I'm sorry, just wait a second. Yeah, just wait. I made a mistake. So what is, so this 2f into k minus 1, right? So yeah, k minus 1 is what? I just wrote something wrong over here. I didn't check that. K minus 1 is what? K minus 1 0 into e to the power dE, right? This is how, and you're told what is that potential applied. So this part, okay, this k minus 1 will be nothing but you will have 2.5 into 10 to the power minus 9, which is k minus 1 0 into exponential of b minus 1 into e to the edc. So which is nothing but this minus 18 into 0.3. What you found in the last question was k minus 1 0. So here you are finding out k minus 1. Please solve that. Instead of looking into the answer, just also try and check, because for those questions are not graded, because the that answers given there are wrong. So that's why I'm asking you to solve it. So how much you're getting when you're multiplying it? Are you having any doubt? I'll give you 1 minute. I've written down all the values. Please multiply and tell me what value you're getting. Can someone tell the answer without looking into the answer key given there?
Is it 2.178 into 10 to the power minus
Minus?
9?
Minus
10 to the
9.
power minus 9 and 10 to the power minus 6.
What
10
is
to the
the
power
unit? 10 to the power minus?
minus 6.
What is the unit? Did you multiply this 10 to the power 3?
Yes, 10 to the power 3 into 10 to the power minus 9. So it is 10 to the power minus 6.
Okay.
So it is 10 to the power minus 6. Then 96485 multiplied by 5. Because 2.5 into that 2, which you written n equal to 2 and
Yeah.
this 2.5.
Yeah.
So that would be 5. So
Yeah.
96485 into 5, that is 48242.
Yeah.
That is multiplied with e to the power minus 5.4, because here
Yeah.
minus 18 into 0.3. So
Yeah.
that is e to the power minus 5.4.
Yeah.
That comes out to be 0.00451.
Yeah.
Finally, it is 2178 into 10 to the power minus 6.
2178 into 10 to the power minus 6. Okay. So in milliamps per centimeter square, right? So you want it in micron. So micron
Yes.
means you have to divide it by 10 to the power minus 3. I mean,
Yes.
yeah, right? So when you do it, you will get
2.178 into 10 to the power minus 9.
no. You have to see, milliamps is a greater value. You want to convert into micron. So you'll be multiplying by 10 to the power 3.
Yes.
Right? So you'll get something like 2178 into 10 to the power minus 3.
Yes.
So if I am writing, I can write this 2.17. micron per.
But here they have given milliampere centimeter raised to minus 2. Their answer is between 0.9 to 1.1.
See, that question is not graded
The answer
because of that question is not graded for. It is given in the right side. Please see the mark distribution for the question. It's not graded because the final answer for that question, which is provided in the answer key, is wrong.
Right.
Okay, so here you'll get that as 2.17.
Yes.
Okay.
2.178. Yes, correct.
Yeah. Now the next question is to find the magnitude of anodic current density at E equal to 0.3 volt versus equilibrium potential is that this much. You are supposed to find it in milliamps per centimeter square, and conversion is given 1 mole, 1 molarity equal to 1 mole per liter equal to 10 to the power minus 3 moles per centimeter cube. So same way as in the previous case. So the again write so this is for the anodic current density, that is for the forward reaction. So the only difference here it will be is you have to find out you have to write properly what is the IF for the forward reaction and then substitute all the value, you will get the answer. So first someone tell me what is the IF equation for the anodic current. What is IF? The equation for the forward reaction. No one? How will it be? Same like before. It will be NF. So here N is 2, 2F into K1 into concentration of M solution 2 plus. Am I right?
Yes.
Now substitute and tell me the answer. I'll give you 2 to 3 minutes. Please do. So same like before, this will be 96,485 into 10 to the power 3 milliampere second per mole. M solution 2 plus value is given as, okay, I have not shown you the value, you didn't ask me also. It is 25. So first part of the question is given. Concentration is 25 millimolar. So here it will be 25 millimolar. So you want it in moles per centimeter cube. So how will it come? It will be 25 into 10 to the power minus 3 moles. And you molar 1 molar. So and 1 molar is 10 to the power minus 3 moles per centimeter cube. So if I do that, it will be 25 into both the 10 to the power minus 3, 10 to the power minus 3. It will be 10 to the power minus 6 mole per centimeter cube. Right? Now what is K1? K1 is K10 exponential B1 into E. So K10 value is again given here. It is 10 to the power minus 4 centimeter per second. Exponential of, what is B1? 20.
20 and multiply by 0.3.
Yeah, what do you get finally the answer? All the values are given, you just have to substitute and find the answer. What is the answer? It will be like 2 into 96,485 into 10 to the power 3 into 10 to the power minus 4 into exponential of 20 into 0.3, and then you have another 25 into 10 to the power minus 6. What is the final answer? Anyone? No one is getting the answer? Okay, then I'll write the final answer. It is 194.6. I'm getting, so it should be something around 194, 193 and 195. Is anyone able to get some answer around this?
It's 1.94 into 10 to the power minus 7 is coming. 1.94 into 10 to the power minus 7.
Did you multiply 10 to the power 3?
Yes, 10 to the power 3 into 10 to the power minus 4. So it is 10 to the power minus 1. And at the end, it is 10 to the power minus 6. 10 to
Yeah.
the power minus 6 into 10 to the power minus 1. That is 10 to the power minus 7. And the remaining, I have multiplied 2 into 96485 multiplied by 2.718 into raised to 6.
I didn't
To the
get
power
you.
6. 2.718 raised to 6. That answer is coming 1.94 into 10 to the power minus 7.
96,485. okay, into
Yes.
you have 125, okay, and you have 2 also. 2 into 96,485 into 25, and you have an exponential term which is 20 into 0.3. When you do that, you are getting some, I'm getting some big value, 1946241,357. Then with that, if I'm multiplying, what to say, 10 to the power minus 6, 10 to the power minus 4, and 1 10 to the power 3, that is 10 to the power minus 7, I'm getting finally 194.62. Because you're getting very small value when you're multiplying 96,485 with other terms. You see, it is 96,485. You have a 2 in front of that. So that itself doubles that value. Then you're again multiplying with 25. And you have something in an exponential raised to 6. So that exponential raised to 6 itself is around 400. Okay, so it's a huge value. You have made some mistake there.
Yeah,
Are you
we may
getting?
committed mistake, maybe. Right.
Please try to rectify the mistake, because you can expect same kind of questions for your final exam also. So if you're not, if you make, that's why I'm writing step by step, in the sense how each value is coming, I'm writing because you shouldn't make this mistake in your final exam. Mostly you will, and like if you're doing it your place now, you can use your calculator, but when you're going to exam hall, you'll be using the PC calculator. That is also difficult. So that's why I'm telling, make sure you rectify the where you're making the mistake, so that you won't repeat that again. Okay. So I'm getting around 194.6 milliamps per centimeter square. When kinetics is rate limiting, the Faraday impedance of a simple electron transfer reaction can be modeled as simple reactor, simple capacitor, capacitor in parallel
Excuse
with a
me.
resistor. Yeah.
Excuse me, but correct answer what they have given is between 90 to 110
Again, if you
milliampere
see
something.
if you see that question is also marked 0 mark.
Okay.
Right side, not your mark. So you're given that question is not counted when you people are graded. Both these questions, they are nullified. So I wanted to show you the right answer.
Okay.
So the next question is, when kinetics is rate limiting, the Faraday's impedance of the simple electron transfer reaction can be modeled as simple reactor, simple capacitor, capacitor in parallel with resistor, none of the above. Who can tell? Any answer? So
Simple resistor.
yeah. So what does this mean? If anyone has any doubt with regards to the question, they're asking for a simple electron transfer reaction, that is no adsorbed intermediate or anything. When you're modeling it, what will be the Faraday impedance, or when you solve that impedance expression and you get something, how can you what to say, model it? So how do they get that? If you remember the first mechanism that we have studied, that was some of the ferro-ferri redox couple, that is A giving B plus E minus reversible reaction. When you solved for such a question, you would have got final answer as something like Z equal to 1 by F into BF. BF, F for the forward reaction, again KF DC. So if you can turn around your page, you will see that. So this A, so I'm writing it for a reaction where A gives B, and you have forward reaction and backward reaction. So this is the equation you would have got. So you get an expression that is independent of omega. So all are constants. So there is nothing that is a function of omega. So this kind of equation which all are constant, you can modify it using a simple resistor. So if you are coupling it with the, I mean if you include the this what to say, the double layer and the solution resistance, so you know this is the Faraday impedance. So they're asking for a simple electron transfer, what will this ZF be? So here you can see it is all constant. So this will be nothing but it will be of this form. So this is what is asked, and it's a simple resistor. Okay, anyone has any doubt? If not, we'll move to the next question. So now you are given a reaction where M gives M adsorb plus electron, and that is a reversible reaction, and in the standard notation the fractional surface coverage theta of the adsorbed intermediate M adsorb plus is described by, who can tell?
It's third one, k of 1 minus theta minus k minus 1 theta.
Okay, anyone else has any answer?
This second one.
Second one. Okay, so let's identify what is a mistake. So the second one is correct. So now how do you say that? So you see, they have asked to tell the fractional surface coverage theta, okay, of the adsorbed intermediate. So first thing you have to identify is in which all reaction M adsorbed is involved. Okay, so you have M adsorbed here, and it's a reversible reaction. So forward and backward reaction consist of theta. Fractional surface change is happening. Surface coverage or theta value keeps changing in the forward and backward reaction. Again, in the third reaction or the second step of mechanism, also M adsorbed is involved. So in all the reactions, M adsorbed is involved. Now, if M adsorbed is formed during the reaction, that is, if you see the first step, that is M gives M adsorbed. So M adsorbed is formed if the forward reaction is happening. So can you tell me in the forward reaction, will the theta value increase or decrease?
It's positive in the
Increase.
Sorry, I
Yes.
couldn't hear that. Right?
Increase.
Increase. So in the forward reaction M adsorbed is formed, that means the fractional coverage of that adsorbed intermediate will increase. So it is increasing. In the backward reaction, M adsorbed is getting consumed and it forms M. Similarly, in the third reaction or the second step, you will see M adsorbed is getting converted to M solution. So there also adsorbed intermediate is getting consumed. So when theta value is increasing or when M adsorbed is forming, the surface coverage of that adsorbed intermediate increases. So in such a case, we will give positive. If it is getting reduced or it is consumed, we will say negative. So we have already identified that in all the three reactions, M adsorbed formation is happening. So I mean M adsorbed is involved. So it will be K1. So if theta is the fractional surface coverage of M adsorbed, what will be the available site for M? The rest of it. So that is 1 minus theta. This K1 into 1 minus theta. Backward reaction M adsorbed is consumed. So I'll write K minus 1. Theta minus K2 theta. So this is the formula. Okay, so that is option number 2. Any doubt? In that case, we'll go to.
In which case fourth option will come? In which case fourth option? Because here in the last reaction, M adsorb is formed or consumed.
In this fourth step, it is plus K2. So that means
Yes.
theta is formed. So if the reaction, the first step is as such, and instead of the second step is something of this form. So here if you see, theta is getting consumed. I mean formed. Theta is formed. So it will be plus k2 theta. So please understand like what it means and then you do, it will be easy. Okay, these questions are easy, do not make a mistake. So the next question is a continuation of that. In the same mechanism, the steady state fractional surface coverage. So how to do it? You will, so it's a steady state, so that means you have to equate dou theta by dou t to 0. And please tell me what is the value. So this is the equation. So the next question is just to equate that to 0 to get. So basically if you see, all the questions are related. If you make one mistake in one question, you will get corresponding questions also wrong. Okay, so make sure that you don't make a mistake in a question. That's why I told numerical problems also. If you see that last one, Faraday current and everything, it took value from the previous one, that is k minus 1 0 that you found in the first part. So all the questions are related. Please don't make a mistake. So what is a steady state?
It is K1 DC divided by K1 DC plus K minus 1 DC plus K2.
Yes, that's correct. So I hope everyone has, yeah, I hope everyone has got the same thing. So I'll just write it down. K1 1 minus theta k minus 1 theta equal to 0. Now what I'll do is at steady state, so all this will be in DC. So I am just taking all those terms with theta to the other side. So it shall have K1 DC K minus 1 DC plus K minus 2 DC. So when you do it, you will take it down. So you will get K1 DC by K1 DC plus K minus 1 DC plus K minus 2 DC. Okay. So the next question is, in the same mechanism, the Faraday current is given by. This is a mechanism. You are supposed to tell what is a Faraday current. So this is the equation.
Second option.
Second option.
In the last reaction, electron is not involved, so we have
Correct.
to consider only
Correct.
forward and reverse. That is,
yeah.
second option is correct.
Yeah. So if anyone makes a mistake, I'll just explain again. So it is nothing but is NF into rate. So here N value equal to 1. Okay. And so you can take it as F into rate. So the as told, this one is the only electrochemical reaction. This first step. The second step is a chemical step. So you will take only the first one. So which is K1 I'm sorry. K1 into 1 minus theta minus K1 theta. So second step does not involve electron. So I will say that step is not involved. Okay, so that's correct. So now the next question, the same mechanism. Okay, I left out a question, I think. So in between that, there is a question which says you have to find theta dash. Okay, if you refer that, you will see there is another one which says you have to find out theta dash value. Please find out theta dash value. How do you find theta dash? Which equation you have to substitute to get theta dash? Theta dash is what? Dou theta by dou t or dou e? Is it the fractional surface coverage variation with respect to time or with respect to potential?
Dou theta by dou t.
No, it is with respect to potential. This corresponds to the variation of surface coverage with respect to potential. How do we find that? Which equation will we be substituting in to find out theta dash? How will they do it? Anyone? This kind of lengthy is not that much, just a half a page. You need to know how you derive it. So which equation? We will be substituting into the theta balance equation. You will be substituting this in place of d theta by dt. So you should know how is d theta by dt and d theta by de related. How are they related? I can write d theta. If you are not able to follow, please let me know. D theta by dt can be written as d theta by de into de by dt, right? Now what is E? E is nothing but EAC naught e to the power j omega t, right? So if I am differentiating it, if you're not able to follow any step, please let me know, okay? d by dt will be nothing but EAC naught omega j into e to the power j omega t, right? When I differentiate it, this is how I'll get. Now I can again combine this along with this to form EAC. So finally, this will be nothing but j omega EAC. Is this correct? So we found out the substitution. Now again if I do here, I'll put that back here. D theta by d is nothing but theta dash. And d by dt I get from here is j omega EAC. Are you able to follow that? Are you able to follow what I have done?
Yes.
Okay. So you found out this much. Now what I have told you is you have to substitute back to which equation? This equation. So you already found out what is d theta by dt now. We'll substitute this. What is k1, k minus 1, k2 and all? It's like you have the expression in terms of EAC. Again, theta is something like theta equal to theta SS plus theta dash EAC. Substitute everything. Can you just try it? I'll give you a few minutes, 3 minutes or something. Please try it. If anyone has any doubt, please do ask me, okay?
So here d theta by dt is equal to this expression divided by gamma.
I didn't get you. Into gamma. Yeah, but you have to substitute. You have to know. Here also, if you see all these terms, K1 is what? K1 is K1 DC into 1 plus B1 EAC, right? Similarly, K minus 1. And K2 is a chemical reaction step, so it is a constant, doesn't depend on potential. You can put directly K2 itself. Now, what is this theta? Theta is theta SS plus theta dash EAC. So here on the LHS side also you have terms with theta dash. You have to take them and you have to segregate them. Then you will get the expression. So whenever an expression is asked for, you have to make it in terms of constants, the simple constants that are already known. Anyone able to get this? If not, I'll solve it. So this is the first part, right? So you've understood d theta by dt equal to theta dash into j omega EAC. So now the equation is k1 into 1 minus theta minus k minus 1 theta minus k2 theta equal to this gamma into d theta by dt. Gamma d theta by dt is nothing but we found it as theta dash j omega EAC. Now what you have to do? I'll write this in the next page, okay? Because I need some space. This is little lengthy derivation. So you get that as gamma j omega theta dash equal to k1 is nothing but k1 dc into 1 plus d1 EAC into 1 minus theta, right? Yeah, so 1 minus theta means 1 minus theta SS minus theta dash EAC, right? Now what is the next term? Minus
In the
K2,
left side, EAC will not come in the left side. Gamma j
yeah,
omega theta dash into
yeah,
E.
EAC is there. Thank you. I forgot. Okay, minus K minus 1 DC 1 plus D minus 1 EAC into theta. So theta means theta SS plus theta dash EAC. Right? And what is the next term? Minus K2. So because it's a chemical step, it is not dependent upon the potential. So I can write as K2 itself into theta. So that is theta SS plus theta dash EAC. Who can tell the next step? What has to be done?
We have to compare, and in those the terms which contains EAC should be considered.
Yes,
Terms which
correct.
does not contain EAC,
Yes.
that should be cancelled.
Yeah. So please start doing. I'll also do meanwhile. So when you solve it, so I'm opening the brackets. So how will it be? K1 DC into 1 minus theta SS. So that's the first term. Again minus K1 DC into 1 into theta dash EAC. What is the next term? Plus K1 DC B1 EAC one minus theta SS. That's it. If I multiply again K1 DC into B1 EAC into minus theta dash EAC, there will be EAC square. So that term will be very small and we can neglect it. Now what about the next one? Next one is K minus 1 DC theta SS minus K1 minus 1 DC theta dash EAC I'm just opening the bracket, just check if you're getting the same answer. So these many terms will be there. Then what is the next step? Are you getting the same? Now all the terms without EAC will, all the terms without EAC will be cancelled. Now what I'll do? I'll take, so you see for all the side, all the terms are having EAC. Now all the terms with theta dash can be taken to the other side. I'll add one more slide. So now I'm just rearranging and I'm taking all the terms with theta dash to the other side. So which will give me theta dash j omega gamma plus K1 DC plus K minus 1 DC plus K2 equal to V1 K1 DC 1 minus theta SS minus K minus 1 DC B minus 1 theta SS. So finally theta dash will be nothing but B1 K1 DC 1 minus theta SS minus K minus 1 DC B minus 1 theta SS whole divided by j omega gamma K1 DC. Basically, you have to take this down. This entire thing will come down here divided by this entire thing will come here. Okay. Are you able to get the same? Are you able to get the same? Anyone please respond. Are you able to get the same? So which is the option? I mean, okay, I have not given that. So this is the answer. If anyone has, I mean, you are checking on in the page, you will see this is the option. Is anyone checking? Am I audible?
Yes, you are audible.
So is this option there in that question?
No. This option is not there.
This should be there. I had checked it. I forgot to add the slide. Which all options are there?
First one, that is B1 K1 DC minus B minus 1 K minus 1 DC divided by denominator is right, but numerator no.
None of them have two terms. Just check towards the right side what is the mark provided for that question. Weightage of that question for evaluation is how much? For this assignment, 3 questions were given 0 weightage. I think this is one of the question. Are you able to see that? If the question is having 0 weightage, towards the right side of that question, 0 mark will be written. Is it so? Can someone respond? So when I checked, it's having 0 weightage. So that means that the options given there are wrong. So this is the right answer. Okay. So now the next one is, what is the impedance? Yeah, you can do this. I'll give few minutes and then we'll decide. So how do you find the impedance? Please mute, like someone has unmute and the sound is little high. Thank you. Anyone can unmute if you have any doubt. Okay, that's not an issue. Okay. So how do you proceed with this question? You're supposed to find out the Faraday impedance. Can anyone tell how to proceed? How do you proceed with this question? So you need to find out ZF, which is the impedance, which is the relation between current and the potential, right? So how do you start about? You can write the equation for IF. And IF is nothing but K1 1 minus theta minus K minus 1 theta. We had already discussed that the last step is chemical step. No electron is involved. So I can write like this. into f. Now what to do next? I have to expand k1 and theta and all. Are you able to follow this? Okay, I'm just expanding this. Is anyone able to get this derivation? So now from this we know that this term k1 dc 1 minus theta ss minus k minus 1 dc theta ss corresponds to if dc. The rest everything corresponds to if ac. So I'm taking out EAC. So we have already done this multiple times. So as a simplification, I mean what you have to do is you will get something like IF equal to F to B1 K1 DC 1 minus theta SS minus B minus 1 K minus 1 DC theta SS minus K minus 1 DC. And there'll be an EAC, which I'm taking that side. This is nothing but ZF inverse. So this is corresponding to, so there'll be, sorry, I forgot to write this completely. We have theta dash here at this side with this term. So this is the option. Anyone getting this? Any doubt? Any doubt? Okay, then we'll move on to the next one. So the first question is the relationship between the electrochemical rate constant and potential is. How are they related? Anyone?
Exponentially.
Exponentially. So yeah, I thought everyone left. Are you able to get the same answer for this question? Just try it out. You will be. You can expect such questions for the final exam. Okay. So yeah, K is nothing but K naught exponential to the power B. So you can know it's exponential. In a 3 electrode cell, it is preferred to have large area of counter electrode. Is it correct or not?
True.
So we know that in order to reference electrode should not allow the current to, large amount of current passing through it. It can become polarizable. It cannot give a standard potential drop. So what do we do? We use the counter electrode. So all the current that is passing through the working electrode should pass through the counter electrode. But if the counter electrode area is small, the current per unit area will be large. So in order to prevent that, you're supposed to provide and you're putting an unnecessarily load on the instrument. So the way to overcome is that you have to provide a large counter area. Choose the correct option when when an alternative sinusoidal potential is applied across the capacitor under steady periodic response, the current leads the potential, lags the potential, is in sync with the potential, none of the above. So you will get something like, tell me.
Leads the potential.
Yeah, leads the potential. In the complex notation with J being the square root of -1, if the sinusoidal potential of angular frequency omega is applied, then the impedance of an inductor with inductance L is given by
J omega L.
J omega L.
Third one.
In the complex notation with J being square root of -1, if the sinusoidal potential of angular frequency omega is applied, then the admittance of the capacitance is given by
J omega C.
J omega C. So be careful if it is admittance or impedance, etc. So you're given 3 resistors, R1 equal to 50 ohms, R2 equal to 30 ohms, R3 equal to 10 ohms. When they are connected in series, the net impedance is what is it? It is series connection. So it is nothing but 50 plus 30 plus 10, which is 90. Now the next question is consider 3 resistors. R1 given is 50 ohms, R2 equal to 30 ohms, R3 equal to 10 ohms. When they are connected in parallel, net impedance is what?
1 upon 50 plus 1 upon 30 plus 1 upon 10. So that comes out to be 6.52.
Yeah, and you have to inverse that. So it is 6.52. For a capacitor with a certain capacitance, the relationship between current and the potential E in a given time domain is given by
I equal to C d by dt.
Yes,
Second one.
that's, yeah, so that's a direct. Yeah, next question. A capacitor is connected in series with a resistor. The differential equation describing the current, overall potential, and the potential drop across the capacitor is given by. What is it? So this is the equation for capacitor. So it should be I equal to C D. It is the change in current, I mean change in potential across the capacitor. So it is C D C by dt. Now across we are equating the current, this current to the total potential drop across that circuit, which is nothing but E minus EC by R. I hope that is clear. So now the next question. Using the circuit given below, calculate the impedance at a frequency of 100 ohms. So how do we proceed with this? Who can tell the answer? You're supposed to find out ZRE. So before that, you should know the ZRE is R. So you have to write the entire equation. So if you remember, we had done question of this kind before when a resistor and is in parallel to a capacitor resistor together. We had written that the impedance total can be written as R1 plus R2 by 1 plus R2 omega C whole square minus R2 square omega C by 1 plus R2 omega C the whole square. So this is the equation for such a, so how did we solve it? We first found out, if we, without substituting the values, I found out what do I get if I make this in parallel. Okay, that will be 1 by, I mean inverse of 1 by, I mean it will be something like 1, if I take they're in parallel, so it will be j omega c plus 1 by rt the whole inverse, and you will get the equation. Then I'm adding our solution to it. So I've got something of this kind. Now the question is find out ZRE, the real part of the impedance, which is R1 by R2 plus, I mean R1 plus R2 by 1 plus R2 omega c the whole square. What is it? So when you solve it, you should get something of the form 52.90. Please try it. Okay. So these questions are easy to get. We have discussed a few of this kind during our first part. So same for which the imaginary part of the impedance have to be found. So which is minus R2 square. Don't forget the negative. Many people make that mistake. Negative 150 the whole square. Omega will be nothing but 2 pi, f is 100, right? C value C value is 20 into 10 to the power minus 6. One plus R2. So here what I meant by R2 is that the one in parallel, okay? Omega is 2 pi f. So this 2 pi f, 2 into 3.14 into 100, if you do, you'll get 628. Okay, so I'm substituting 628 directly. C is 20 into 10 to the power 6. So when you substitute all this, you're supposed to get minus 62.110. Okay. In the above circuit, what is the magnitude of impedance if frequency is 0? What will happen when omega tends to, frequency tends to 0? When frequency tends to 0, 2 pi f also tends to 0, right? So 2 pi f is nothing but omega. So that will also tend to 0, right? Now when that,
Yeah, R1 plus R2.
yeah,
So
so,
R1
yeah,
plus R2 is 150 plus 20, that is
yeah.
171.
So, yeah, so ZC will be something that tends to infinity. So nothing will pass through this part of the circuit. So it will be directly going like this. So R solution plus RT, which is nothing but 170 ohm. Same way, what is the magnitude if frequency tends to infinity? This means omega tends to infinity. Impedance of capacitor tends to 0, it's short circuit, so current can easily pass through this path. So it will be our solution. This is 20. So yeah, so these were the assignment questions I wanted to discuss today. So we have already completed, I think, 4 assignments, right? So yeah, now only, I think, yeah, it's only 4 more, so it will go well. So, but someone asked me about the derivation. So for the next class, I'll do the derivation first and then discuss the assignment questions. Okay. I hope that should do good because someone did ask me. Because you see, the assignment questions are lengthy, so it will take time. It's difficult to complete. So I am doing 2 assignments also. It becomes, and if problems are involved, it will take time. So for the next class, I'm planning to do the derivation first, and then anyway, before the exams come, I'll try to finish almost all the assignment questions also. Okay. So yeah, that's
Initially, you just explained the summary. So
yeah.
in that summary, what was the formula of CAS?
CAS, you want the surface for which one? You want it at for the infinite or semi-infinite or the finite one?
That is
I think finite one.
yes.
So yeah, sir had told in that, but anyways, for the next one, I'll do the derivation first, okay? Because if like some people want to do the questions, I understand, but altogether in 2 hours is difficult to finish. So CAS equal to DA
Bracket CA
CAB
bulk upon
by,
thickness
yeah,
plus
plus
K1 minus DC minus 1 DC C bulk plus K minus 1, yeah, upon DB, yeah.
So anyway, for the next class, I will do these derivations. Okay. It will take time again. I don't know how much it will take the time to, derive everything, but I'll try my best. Because everyone should see the videos and understand the derivation. Because if we sit with the derivation, then we cannot do other problems. That's why. Okay.
Lakshmi, I have a question regarding this. So for charge transfer, we have to ignore the j omega part that it comes in the same assignment. So the charge transfer, so 1 upon root j omega dA. So we have to ignore that term. For the polarization, what would be that? For polarization, omega becomes 0.
Yeah.
So how we have to omit, or how?
See, for polarization, omega tends to infinity. For charge transfer resistance, not omega. Yeah, omega tends to 0. Low frequency regime is what you find in the charge transfer resistance.
Okay. So for how we have to take care of j omega, then root j omega take care. So for the charge transfer, we have to consider what value, and what for polarization, what value we have to consider. So because in the lesser lecture, I found that for the charge transfer, we have to omit this 1 upon root j omega dA, this term.
Yeah, that will be 1 by everything else. The other one will be corresponding to Warburg. J omega,
Yeah. For polarization, what would be the condition?
Polarization, you can put omega tends to infinity.
Then what would be this becomes it plus infinity? Then what would be that?
That you have to do, right? You know what is the impedance equation. Put omega tends to infinity, you will get an equation, right?
Okay.
That's your assignment question. We can discuss it in the next class.
Okay. I will try to.
Yeah.
And apart from this, Lakshmi, I need one from your opinion. We are doing the EIS testing in our lab. So at the lithium ion cell. So we are doing at 25 degree, 45 degree, and 0 degree. So some charge and discharge cycles. So after some 50 charge discharge cycles, we have to do the EIS. So should we do the at the respective temperature, or we have to do it at ambient temperature? 25
You have to do it at the respective temperature. If you have done your charge discharge at particular temperature, then you have to study the impedance also at that temperature, right?
Okay. Because it's difficult to take out that knob probes in the respective chamber.
I mean, that's how you like. If you want to
chamber.
study the impedance at that particular temperature, you need to. Your system should also be at that temperature, right?
Okay.
Yeah.
Understood. Clear. It should not be that ambient temperature. So means degradation we have to do at the 45 degree or 0
Okay.
degree.
That is also, it depends on how how you or your guide or how they are. I cannot make a comment on that. So if you're studying the degradation at that particular temperature and you are comparing everything at room temperature, that is also a possibility. But there are also equipment where you can maintain the temperature and do the impedance at respective temperature.
Okay, understood. So both the scenario we can do.
No, it depends. Again, I told it's not. I cannot make a comment on that. It depends upon.
It's just a suggestion that I need your opinion on.
No, I cannot. That's what I'm saying. I cannot say that like that, right? So it depends upon your guide. If you're a student, it depends upon your guide and you who to decide. So I cannot say on that. So if you're doing the impedance, like you want to. So I have seen people who are doing it at that particular temperature itself. So I don't know. Yeah.
Okay, understood. Clear. Thanks, Philip.
Yeah. Okay, then that's
Just
all.
now you had mentioned that formula of CS, in which there is no, you haven't mentioned anything about temperature. But in assignment question, they have given temperature 25 degrees Celsius.
Okay.
So is it necessary to substitute this value of temperature, or it is independent of temperature?
So is there any K value coming? You can have a relation with K and T. I'm not sure if any activation energy is given then. Otherwise, it's just given for, that just to show that yes, this experiment is conducted at room temperature. I've not seen the question actually. I forgot to this time check the questions.
They have given value of dA.
Okay.
dB,
Yeah.
then CA
Yeah,
per
so that's just to show
civil.
that the values of diffusivity are given at this particular temperature. So
Yes.
that has nothing to do with the way you solve it.
Temperature is not additional information. Means you are
Just an
providing.
additional information just to show the rate constant.
I think it may be used in another questions 13, 14.
Okay, I have not seen that. We can discuss it the next time.
Okay.
Yeah. Okay then. Thank you everyone.
Thanks.
We'll discuss in the next one. Thank you. Good night.
Bye. Good night.
Bye.